Suppose we have the sum of the three angles of a triangle equals to pi radians. We need to show that cosine of 2a added to cosine of 2b plus cosine of 2c, the sum equals to -1 minus 4 times the product of cosine a, cosine b and cosine c. Okay, let us begin with our proof. Now here, this is an example of a conditional trig identity. Now it's conditional because if we consider the standard identity sine squared theta added to cosine squared theta, so the sum of the squares of sine and cosine, that's always equals to 1. This is a standard identity because it's going to be true for any value of theta that we choose. However, for this particular problem, the choice of the angle A, B and C, that has to be very specific here. The choice of angle A, B and C must be such that they sum up to give us pi radians. That's why it's a conditional trigonometric identity. We'll start the proof from the left hand side. On the left hand side we have cosine of 2a added to cosine of 2b. To it we are adding cosine of 2c. So what we will do, we're going to combine the first and the second term by using cosine of c added to cosine of d. So that's going to give us 2 times the cosine of angle c plus d over 2 multiplied to cosine of the difference c minus d over 2. So here c corresponds to 2a and d is going to be 2b, such that we are going to get 2 times cosine of angle a plus b multiplied to cosine of angle a minus b added to, we have cosine of 2c. This is a standard formula, so cosine of 2 theta. So it has got three different forms. So one form is cosine squared theta minus sine squared theta. Now if we use this standard trig identity, then this is going to have the form 2 times cosine squared theta minus 1, and we have 1 minus 2 times sine squared theta. Now of these three forms, we're going to use the one that's going to give us -1 on the -1, because we need -1 on the right hand side. So it's better to use 2 times cosine square theta minus 1. Now in our case, angle theta is actually c here, so we should get 2 times cosine squared c minus 1. Okay, now next what we will do, we're going to use the condition that a plus b plus c equals to pi, and we're going to replace this a plus b with pi minus c. So that means we get 2 times cosine of the angle pi minus c multiplied to cosine of the angle a minus b added to 2 times cosine squared c minus 1. Now what is cosine pi minus c? Now there's a standard formula. We know that whenever we have cosine of pi minus some angle theta, this is equals to negative cosine theta. Now here pi minus theta lies in the second quadrant, where cosine function is always negative, and that's the reason why we're getting this negative sign here. Then cosine of pi minus theta gives us negative cosine theta. Now for our case, we have cosine of pi minus c, and that's going to give us negative cosine c. So we get -2 times cosine of c multiplied to cosine of the angle a minus b added to 2 times cosine squared c minus 1. Okay, now from this first and the second term, we can take 2 cosine c as the common factor. So let's do one thing. So let's write -1 as the first term, and from the first and the second term, we're going to take -2 times cosine of angle c as the common factor. So that means that is going to get multiplied with positive cosine of a minus b minus cosine of the angle c. Okay, fine. So our next task is going to be to manipulate cosine of a minus b and cosine of c. So here what we'll do, we're going to rewrite cosine of c. So we have -1 minus 2 times cosine of angle c whole multiplied to cosine of a minus b. Now cosine of c, we can also rewrite it as cosine of the angle pi minus a plus b. Right? So here cosine of pi minus some angle theta, that's going to be negative cosine of that angle. So we have negative cosine of a plus b. So that means cosine of c. So here we have negative cosine of c, meaning we are going to get here positive cosine of a plus b. Okay, now We have -1 minus 2 cosine of c. So we have the sum of two cosine function. We have already talked about this. So this is going to be 2 times cosine of, we need to take the sum of them, the a minus b added to a plus b. That's going to give us positive 2a, and we have 2a over 2. Multiplied to cosine, we need the difference, so we get negative 2b over 2. Let's further simplify. We have -1 minus, so 2 times 2, that's going to give us 4. So we have 4 times cosine of angle c times cosine of angle a times cosine of negative b. But we know that the cosine is an even function, meaning whenever we have cosine of negative theta, that's simply the same as taking cosine of theta. Fine. So that means finally we are getting -1 minus 4 times cosine of angle A. The cosine of negative B becomes cosine of B multiplied to cosine of C. So this is going to be the right hand side. The right hand side. So hence we can say that hence if we take cosine of 2A added to cosine of 2B plus cosine of 2C, so that's going to be equals to -1 minus 4 multiplied to cosine of angle A times cosine of angle B times cosine of angle C. Whenever we have A plus B plus C equals to pi radians. Hence proved.